I'm opening some file. Okay. Okay, give me a few more minutes. I'm preparing the file. Okay, can you see my screen now?
Yes.
Okay, so today I want to talk about something on the formalism, or maybe you can think of this way to decouple the process of the modeling and coding. So I think I have mentioned this a few times, is that modeling does not equals to coding or development, okay? Because a modeling can just come up with a conceptual model, and not only the conceptual model, but formally described model, okay? A formally described model. Then you can represent this model by using graphical language. Okay, this is one way. Then algebraic language. Okay, this will be the second way. You can also use a tabular specification. Okay, you put all the things into a certain table. So this will be a third kind of the third way. Okay, so at least you can use this a three different way to formally represent a model without coding it in any programming language. Okay, so this is actually an idea of this formal description of the model, or maybe the formalism. And also, I think I mentioned to you a few times that there's a different kind of the formalism. You have an event-based, we'll have a state-based, also have the activity-based formalism. So each formalism actually using a different set of the graph, use a different set of the tabular specification, and using a different set of the algebraic notations, okay, to represent the model. They use a different set, totally, some kind is actually totally separate, okay. By now, what I'm going to introduce is to you is that what are the formalism behind the O2DES model, okay? When you build a model using the O2DES.NET, so which kind of formalism we should use? It's actually including a partial of the event-based, also including partial of the state-based or maybe activity-based, okay? It's actually a mixture of them. Okay, by now, I think we have not really formed a full comprehensive formalism, but I think what we have now, I'm going to introduce to you, is sufficient for us to understand, okay, certain part of the model. So maybe later we can also use this kind of representation as a way to communicate within the team. Okay, so this is actually just to introduce what we are going to go through today. Okay, so let's go back to the model we built last time. Okay, so for this model, in the parent one, we have a generator, queue, and server, right? So we have different modules. So we actually have a different input and output event, and also static and dynamic properties, okay, for this module. Okay, so now I want to show you that how do we represent it into in a graphical way. Okay, I think a graphical way is actually most straightforward. Okay, so the first is that I want to mention one thing before we go into this one is actually this event-based is actually still something later you will see that this will be some things we are going to use. Okay, but because we're using the O2DES .NET, which actually consider both of the event-based and the state-based mechanism formalism, so that's why this event-based formalism, this kind of graph cannot be solely being used, okay, to represent what we are doing here. So we need to use this one together with state-based kind of a formalism. So we actually use this module diagram, or maybe it can be considered as a kind of the extended class diagram. I'm going to show you, okay? So now we have this generator, queue, and a server. So what we can do is we just draw something for this three. Okay, let me see. I'll set up a new slice. Okay, so today will be a little bit slower because I'm going to draw these things on the PPT. Okay, so what we can do is we actually draw some box. Okay, then this box will be used for represent each of the module we're actually representing here. Okay, so this one will be the generator. Okay, let's just change the color to black. Okay, so after that, I can just do some like copy and paste. Okay, so beside the generator, what we have next is actually the queue, right? Followed by server. Okay, generator, queue, and the server. Okay, now we go to the generator. Okay, we'll look at what are the input event and output events we have. So for this one, okay, we only have one output event, right? On generate. Okay, this will be the output event. But rather, there is not any input events because this generates actually some internal events. Okay, so this will be the only one output events. Okay, so what we do is we will take this one as a output event. So we draw an arrow here. Okay, we draw an arrow here, and this arrow is a point out from this box, okay, to the outside. Then probably we need to change the format of this arrow a little bit by using a different type of the arrow. Yeah, this is the ones I use often. Okay, just want to differentiate this with the other arrow if there is any. Okay, then what we do is we actually write the name of this output events on this arrow. So this one we call the generate. Okay, generate. Okay, back it. Okay, we change the format a little bit. And we put this one onto this arrow. Yeah. So we can do in the way that the parameter, which actually the bracket, actually we can put it on the and below this arrow, just in case that maybe later we will have some event which has like a parameter. Okay, so that's why we will put this parameter here. For example, if it's a load, then what we do is we can do in this way. We can just say it's actually passing a load. Okay, and the type of it is actually load, for example. Yeah, this is some things we can do here. Okay, but for this example we don't have, so that's why we keep it empty. Okay, so this will be the generator. So if you really want to tell people, okay, now I build a module and this module called a generator. So what should you draw? Okay, what should you draw? I mean, represent this model in a graphical way, and this is what you need to have. This is what you need to have. Okay, and probably you can also add a little bit information on this this one to see. No need. So because this is actually event, so there's no like returning type. So as long as on this arrow, meaning this actually output events. Okay, so whatever parameter you want to define, you actually put into this bracket. So now we finish for this generator. Okay, you can see that the way we represent this information is that we do not really zoom inside this generator to see how the event is triggered inside this generator. We do not care from the this outside view. From this external view. So this one actually, I gave a name of this last time. It's called external view. Okay, this one we call the external view. So from the external view, we just see this module with the interface events. So similarly, we can also do for the other modules. Okay, let me just finish all of them. So for the queue, we can see that we don't have output events. We have input events in queue and have an input event of DQ. Both are parameterless. Okay. So what we are going to do is we still use this as same thing. Okay, we copy here, but now is that this thing is actually pointing to the module. It's actually pointing to the queue. Okay, so this one is in queue. Okay, then we also got another ones. We also got another ones called DQ. Okay. So now we finished the external view for the queue. Okay, for the queue module. Okay, now we go to the server. So server, what we have is okay, server, we have an input event of request to start. We have the output event of unstarted, right? These two we do not need to care, okay, now from the external view because it's internal. Okay, so we just do this request to start and unstarted. Request to start, we copy it here. Okay, then you can see that it also parameterless. Then we have unstarted. Copy this one here. So the unstarted. Okay, so for this one, we actually finished the drawing, the graphical drawing for this tree module. But sometimes if you want to like represent more information and put this one more precise, what else we can do is that instead of the box, so we actually can write in what are the static properties of static and dynamic properties of this generator. For example, okay, so in here we can make this one. Yeah, let me see. I can create a class diagram. Okay, it will be a class diagram. Then what we can do is we can draw this generator onto this diagram. Okay. Then you can see that for this generator, this is actually the output events. Okay, so these are actually the constructor, and these are internal events. So these things we want to like just hide them. Okay, I think this one we just have them. So what we need to do is I want to like do something like this. So instead of just write it's a generator, which I mean most likely it will be easier to do on the PPT. So what we can do is we can put in more information here to tell that what are the static properties and dynamic properties of this generator. So I think this might not be a good idea to just copy because you see here we got this two property, but this hourly arrival rate is a static property, and this the number generated is actually dynamic properties. So I think what we need to do is something like this. Probably I use a text box. Okay, so we have this generator. Okay, then we actually have static properties by using, for example, let's just use this dash to see that this is actually hourly arrival rate. Then probably we use a tilde here to see this is actually a dynamic property, the number generated. Okay, so see that, sorry. Okay. Then we'll see that this one is actually a integer. Okay, then this one is actually a double. Okay, so we don't need this one. So instead of just putting the name of this module, okay, so what we can do is we can put in like this set of information here. Okay, why is it? Because when people looking into this module, so they don't need to care about what is inside of this generator, But what they need to know is that based on this information, okay, they actually know that what are the information required to set up, okay, this to construct a generator module, okay. Then this one will be the dynamic information, and also to be more precise, the public dynamic properties. So meaning that while the simulation is actually running, when the module is under the simulation, so from a time to time, so what we can expect, okay, what we can see, what are the value we can observe from this module. So you see that both of these two information actually provide an external view of this module. Okay, so this is some things I want to show to you first. So probably later when we come up with any develop any O2DES module, so this is some graph you can draw. Okay. Yeah, but I think now using the PPT is a little bit complicated. So actually, we're thinking whether it's possible to make up some graphical tool so that we can just click and drag. We can come up with a graph, and all the style is actually very nicely arranged. Okay, so in that case, it will be much better. Okay. So now the next thing I want to show to you, I will still use a simplified version. So meaning that I just use just putting the name. But I just want to add in one more thing. Is actually this one, although I thought it should become of formalism, by now we did not come up with any documentation or do not have a formal definition to see that what this graph should look like. Probably I think we can publish a paper to talk about this one. So if any of you are interested, can actually help me to do me a favor to clear out those things, to think that what is the best way to define, for example, static dynamic properties, whether we should follow a certain kind of the UML, for example, the class diagram, okay, to do similar things. Then we can make this one better, okay. We can actually establish this whole system of the formalism. Okay. By the way, this is a side story, so only if you're interested, you can talk to me later. Okay. By now is I want to show you another thing is what with all the module defined or drawn or using the graphical language, and we call this external view, right? But one thing is that the parents module is something we have not represented here, okay? So meaning that how do we use those different modules, okay? This kind of relationship, how can we represent in this kind of the graph? Okay, so I will show you this thing. Okay, so you see that what we are doing here is we actually connect the generate event to the queue in queue. Then this generator to the server request to start. Then the started to the server to the queue of the queue. Okay, so let's see that from this one. So what does this really mean? Okay, basically it means that we actually connecting this event, the onGenerate, okay, to this one. Let me see. What is the best way we can? Let's move this aside. Yeah, I mean later if you have a graphical tool, then these things will become much easier. Okay, so the first one is this onGenerate is actually a link to connected to the in queue, right? And also this onGenerated is a link to the request to start. Okay, I think I need to use this connector. By the way, I think if you have any comments or questions, you can interrupt me and just ask. Okay, so yeah, I think this will be good enough. Okay. Basically, you see that what I'm doing now is I just want to link this output, connect this output events to the input events of this server. Okay, so we actually link this one. So this two linkage is actually what is represented here. The last one is for the server unstarted. Actually, I'm linked to the q.dq. So what I'm doing here is actually for this server, I link this back to this one. That this will be started. Sorry, there's additional arrow here. Okay, so now you see that, oh, sorry, this will be, said I will use a simple version. So this will be the full one, then this will be, okay, let's just use a simple version here. Okay, so you'll see that this one will become the this structure as I described here. And we see that this structure is actually inside of this module, the sandbox of parents called a parent, right? So in that case, this is what we are going to do. We actually encapsulate these things in this box, okay? Then this one, we give a name. We call this one parent, okay? Then we see that this is actually an internal view. But of course, this is internal view of parent, okay? Meaning that we actually open this box, then we see that what are the internal structure. But one special things I want you to notice is that this is a parent because it's actually a root module, so it does not have any input events in, does not have an output event in, okay? Yeah, but if they have an input and output event in, then we need to check that how this input and output interact with all the internal mechanism here, okay? And also is that this apparent event does not, no, this apparent module does not have any internal events, I mean, directly under the parent, okay? So what does this mean? Is that here, you do not see any like events here, okay? You do not see any event here, like what a generator and the other module have. But of course, because this is also a sandbox, so it's also possible to define some of the internal events here, okay? But this one we'll encounter later, or maybe later we revise this model a little bit to show you what does this mean. Meaning actually it's a mixture of the modular structure and the atomic structure. But this one I will show you later, okay? So now you just need to understand that, okay, for this apparent module, then the connection of the internal module, the representation of them is actually an internal view of this apparent, okay, of this apparent module, okay. But also I want to show you another thing is what is actually inside of the generator, the queue, and the server, okay. So let's go to this one, okay, I copy. Then I will show you how to represent what is going inside this internal view of, for example, generator. Okay, I will show you what is inside of the generator. Okay, so because it's generator, so I will remove the other things, but just keep the generator inside here. Okay, so we try to keep it large. Then this one, yeah, probably I think you can keep it here. You can keep it here. Yeah, by the way, as I mentioned, that this standard is not formally documented. Okay, so I will need some of you's help to check that what is the best way. Okay, we define a standard. Okay, then later we can make this as a graphical tool. Okay, usually what I did is I do not have this one. I just remove this thing. Okay, so what we need to care is actually the event structure, the event relationship. Okay, inside the module. If this is not a composed module, what does this mean? That it does not consist of the submodule inside. Okay, so what we have is actually, yeah, we see this is a generator. In the generator, so what we have inside is actually a one internal event called a generate. Okay, called a generate. So what we are going to do here is we will use exactly the event relationship diagrams format, okay, to draw what is inside. So we have this generate event, right? So that's why we have this it's a circle here, generate. Okay, we have this circle here, okay, to represent the events, okay, called generate. Okay, then this is generate. More precisely is a parameter, is parameterless. Okay, so what we should do is like this one. Okay, Ken. Then the other thing is we will have some necessary informations here. So for each of the events, there are two important things we need to represent. The first one is how does this update the state variable? So here, for example, the number generated plus. So follow this. You can see that we can just follow this standard. We follow this standard. So what we can have is to see that, okay, we have the bracket. So number generated plus. Okay, so this is what we do for the state update. But here I just want to see that in some of the events, okay, some of the model we are doing, so this one is actually quite complicated. Okay, this one is quite complicated. So instead of doing this one, so probably we can have something like, okay, so the state equals to the f of the state. Okay, so maybe this is f1 or what. Okay, so meaning that this f1 is actually some algorithm we're using to process the whole state information, okay, which actually consists a lot of the dynamic property here. Then we can actually spend another maybe page or document to specify what is the algorithm, including in this f1. Okay, so this one, because now it's a simple, so I just do this. Okay, so this is about the update, okay, of the dynamic properties. So what we are going to do next is actually a scheduling relationship. Okay, scheduling relationship. So we actually schedule another generate after a certain arrival time. Okay, so what we need to do here is that we need to have this curve. No, sorry, not this kind. Yeah, this one. This arrow point to itself. Yeah, probably I do it in this way. Okay, then we also change the format a little bit. Okay, so this meaning that this generate will schedule itself, and according to the event relationship diagram, we need to specify the time. Okay, if there's actually a delay, and also you see that we try to according to make it consistent with this standard by using this arrow. So that's why I changed to this one. And make the size of the arrow large. Okay, so you see that this arrow is actually very different from this one, from this arrow. Okay, it's actually very different from this arrow. It's because actually they have a different meaning. One is actually event triggering. This one is actually a triggering of the event. This arrow means the event itself. Okay, it's actually means the event itself, or maybe the interface. Okay, so another things I want to see is that okay, so if we just have an event diagram, this is exactly what does this mean? What is event diagram, relationship diagram should looks like. But now it's because this one is put under this generator module. So meaning that we need to see how this event, how this internal mechanism interact with the interface. So what we are going to have is that, okay, sorry, one more thing that is actually this time delay. Okay, it's about this time delay. We didn't put it here. So what we need to have is to see that, okay, now it actually a delay time, then this delay time is some decision, no, so it's some like a random variable t, okay, so actually follows the exponential distribution with is that okay in terms of then this actually in hours, okay, this actually in hours. Sorry, what is it? Yeah, this is why the sorry, this is why the graphical tool is needed. Okay, if it's a graphical tool, then we don't need to bother those formatting issue. Okay, so okay, now this internal logic is down. So now what we are going to do is we also need to pay attention to this statement. Okay, it will actually trigger this ungenerator to be invoked. Okay, so in that case, what we are doing here is we copy this one. So this event also will trigger this one to be invoked. And this invoking is actually immediately. So that's why there's no time delays on this arrow. Okay, so now is actually we have this internal view of this generator. We know that what is actually happening inside. Okay, what is happening inside? Okay, so now let's also do these things for the other things. Okay, so the second one will be the queue. So let's see this queue. Okay, this is actually the queue. Then what the queue have is the two input events. One is in queue, the other one is actually the queue. Okay, so we delete this one first. Okay, then we see that for this queue, we have the enqueue and the dequeue, and both of this one is actually internal events. Okay, I mean it's both internal events and the input events. Okay, so meaning that these are two things are also defined under the queue. So what we are going to do is we will still have this because it's actually an event of the queue. So instead of just of the interface, we will still have this two events like defining here. One is actually for in queue, the other one will be for dequeue. Okay, then we see the triggering relationship is actually very straightforward. So what we have is that this one, the in queue, will just trigger this in queue, but rather this dequeue just simply directly trigger this dequeue. Okay. And also we see that although enqueue and dequeue does not trigger anything else in this logic, but actually there will be some like update of the state variable. So what we will have is this one. They will have this. What is the name? Is number in queue. Okay, it will be the number in queue plus plus, and this one will have the number in queue minus minus. Okay, so this is actually what is happening in the queue. So now let's go to the next one. Server. So this one is for queue. Okay. Then we go to the next one, which is actually the server. Okay. So for this server, we can go into here. Okay, yeah, probably let's just carry on all the interface first. So this will be a request to start and also on started. Okay, let's just put in this one here. Requested to start. Sorry, the arrow was not there. Okay. So the request to start is here. Then the unstarted was here. Then this is actually the server. Okay, so then we'll see that how many events we have, the internal events we have. Request to start it. Well, request to start will also be 1, okay, because it's also under the server. Then start and end. So total we have this 3 event. So we need to put a 3 event here. One is request to start. Then we have this start. Then we actually have and let's make it a little bit smaller. Okay, so now let's work on this one by one. Request to start. The first one is this input event is definitely linked to this request to start. And also whenever it's started, it's a trigger, then it will trigger this started. Okay, so first we build this linkage. Okay, then we look into this request to start. What does the request to start do? Is we'll make this a number pending plus plus. Okay, they'll make this number pending plus plus. Okay, then it will actually look into a certain condition to say that if the number in server is smaller than capacity, then it will trigger start. Okay, so this one will trigger start, but based on certain condition. So this condition is number in server is smaller than capacity. Okay, smaller than capacity. Okay. So this will be the condition. Yeah, the space is not enough. Anyway. Okay, I try to do this. Okay, then here is actually a condition, so we need to have this as a small tilde here. So now you see that why I'm so eager to look for the graphical tools. Okay, so this will be a condition. So when this condition is satisfied, then we'll trigger the start. Okay, then this will be, yeah, I think this is all the logic about request to start, right? So these 2 things. So now what we do for the start is that the number of pending, yeah, so we just copy this one and paste it here. Okay. Okay, so this is what we're going to update on the start. I mean, if it's more than this, probably you can have a separate slides talking about the procedure, okay? But basically now we only have this 2 properties will be updated. Then we need to schedule the end after the service time, okay? So we need to schedule this and we need to schedule these things after some time. So this time we can actually refer back to this one. We can copy and paste this thing then we can see that this time is actually based on 1 over, the mean is actually 1 over hourly service rate. Okay, we have this end. Right, then we have this invoke for this unstarted. Okay, this revoke on this invoke on this unstarted. Okay, it's here. So now we go to the final event, which actually the end. What this end do is actually update this one. Okay, number in server minus minus. So it goes to number in server minus 1. Okay. Then it will be some condition when it is satisfied. Then it will trigger start again. So it's similar as this one. Just copy these things. Okay, then you can see that what is the condition here is number pending larger than 0, right? So look at this condition, the number pending larger than 0. Okay. So I think that's all. Okay. So that's all we need to have, right? So you see that now is we have this 1, 2, 3, 4. So actually this one can be ignored. This one can be ignored. Probably you want this one to represent the dynamic or the static and dynamic information also can, but this one we can also, for example, put it here. Okay, we can also put it here. Yeah, as I mentioned, is currently I did not really formally define the standard. So yeah, it's actually up to us to see that what is the best way. Okay, so now you can see that this one can actually be ignored, or maybe it can be a simple collapsed version, okay, of what is showing here. Okay, but basically we just need to have this 1, 2, 3, 4. We need to have this for diagram, so we can actually know that how should we code. Okay, so actually this translation can be straightforward. This translation to the code can be straightforward, and based on this graphical language, okay, we use to define a model here. We can actually code a model not necessarily in C# in O2DES.NET, but we can also using the other language, other framework to build this model. So that's why coming out with this 4 graph is actually what I mean for modeling, okay? But rather converting this graph to the code, we call this one development, or the model, yeah, maybe, yeah, the coding now, okay? So, but yeah, because of lack of the graphical tool, or maybe because sometimes the project duration is too rush, so that's why we actually skip this intermediate step. But this will be some things we have in mind, okay? So when you build this model. So now it's just I want to talk a little bit about this internal view of the parent. Okay. So I think today I want to mention about the extension of this one. For example, I just give you one possible. Maybe I still talk about that here. Possible extension. Now I just talk about the possible extension. Is that what if we will also have the structure like this? Okay, we also have this structure like this. We have this hybrid structures into here, meaning that this parent does not only have this internal sub modules, but it also has certain events inside, okay, defined under this module. Okay, so for example, it's something like this. Okay, yeah, and also it will have it will also have, yeah, this is not easy to handle. It also have input and output events for this parent, because eventually this parent might not be the root, but it can also be used under another module. So if that is the case, okay, yeah, maybe later you can help me to come up with a better drawing. Like here, it's a little bit ugly. Okay, probably this one, do something here. Okay, so you see that this one will be, for example, it will be something you need to link from the outside. This input event will trigger this internal event here. Okay, then you see that this internal event will trigger some like other like internal events of this of some of the module here, for example. Yeah, something like this. Okay. Yeah, I think you could understand what I mean is, you see that this queue, for example, is not only triggered by the output event of this module, but actually also triggered by some internal events, okay, which actually passing from the outside, trigger from the outside. And also you see that, for example, this ungenerated output of the certain, like for example, this is server, not only like a trigger this queue, but it also trigger some of the internal events here. Okay, for example, it also trigger here. Yeah, I think it should come from this side. Yeah, see the linkage a little bit. I think a little bit, yeah, I think this will be better. Okay, this will be better. Let's just assume this is the case. Okay. Okay. So basically the idea is that this output event, because this actually event, okay, this unstarted is actually event, this start is actually event. So we can actually using this arrow, okay, to see that this event will trigger this internal start, okay. Then probably we'll go through a lot of other mechanisms. So eventually it will be some other internal event directly under the parent to trigger an internal event of another module, okay. Then we can also see that this output events can be triggered from the events, or maybe can also be triggered from here, for example. Yeah, for example, is actually output of the module. Okay, the output events of the module actually trigger this start. So this will be kind of the extension, which we call the hybrid modeling, meaning that we use both of the module and the internal event structure. So yeah, so I think later in the future example, I will show you that how this is actually handled in O2DES framework. Okay, so by now I think for this session, these the four are most important. This four diagram will be very important. Okay, so now is I want to extend from here. I use this one. Okay, so I want to talk to you about some of the pattern. Okay, some of the pattern where we come out with the modular approach. So you see that now, if you look into this pattern, we can see that, okay, this generator generate something, then it pass into the queue. Then when It also inform the server. Okay, then when the server is available, okay, then they actually call the queue to dequeue something that actually process. So this is what we are modeling here. But have you think about the one problem is that what happens if I want to like extend these things to be to like repeat, okay, these things many times, and this one we call it is actually a tandem queue lah. So meaning that after it's a finished end, so actually I'm going to another queue, then we'll pass into another server. And the case happens sometimes, often it's also a little bit complicated. Is this one? There's actually no queues, okay, in between of the machine. So after one machine is actually directly goes to another machine, okay, maybe followed by another one. Then you can see that once the machine is actually start, I mean capacity is full, then for those one process at this machine cannot even depart it, okay, end this process. So in that case, if we want to do something like this, probably we need to kind of although we can see that we can use the modular approach, okay, to do this one, then we're trying to think through the process and connect the event. But one questions we have in mind is whether there is actually a certain like a pattern, okay, we can observe when we connect like one module to another, okay, whether there's any like a pattern we connect one module to another. For example, when this server need to finish and pass to another server, then probably you need to have a depart, okay, some kind of the arrow, right? Then, but when this depart is not necessarily able to depart because also depends on the capacity of the next server, okay? So also need to have certain either of the event to see that, okay, so when it's available, like what this server inform the queue to dequeue, we also need to have a channel to allow the server 2 to like inform the server 1 to say, okay, now you are able to proceed. Yeah, so if we want to have a certain structure like this, whether we can identify certain patterns from here, and we can actually standardize the connections between the modules. Okay, I think I will give this one as one of the questions to let you to think through. Maybe the next week we can think about, yeah, because tomorrow I think we'll have a session sharing from Monica, and we have a discussion also with me and Riza. And on Friday, we'll have the bigger group session, the training. So that's why I will leave this as a question you can think through. But now I want to try to give you some hint, okay? So this hint is actually about you looking into this one, okay? You look into a communication between queue and the server. So you see, I think we also mentioned a little bit last time. So you see that's actually the passing of the load is completed through these two events. One is actually request to start, the other one is actually started, meaning we pass information here, then unstarted is actually to trigger the physical flow. So one is actually information flow, the other one is actually the physical flow. So one is actually actively passing, I mean, a queue is actively passing information, server is someone passively receiving the information. But the other side, the physical flow, is a server is a one actively passing, I mean, initiate, then the queue is someone to passively receive, okay, this event. So this one pair, okay, of the communication, we give a very friendly name to it. We call this a handshake. We call this a handshake. So when queue want to deal with something with a server, so they need to handshake with the server. And this handshake here, we call this one as a two-way. We can call this one, yeah, probably have a better name. So we can call this one as a two-way handshake. Mean I shake one time, I pass one information to you. When you are ready, you handshake another time with me. Okay, then it's actually get the deal. Okay, so this actually are some things we can establish the protocol. Then we can see that whether these protocols can be extended into other places. For example, when server comes to another server, when server go to another queue, whether we should have another handshake, a pair of a handshake here, and also when a generator talk to the queue, whether you should have another handshake here. Okay, yeah, probably you see that the wait generator dealing with queue is actually one-way handshake. It's just have a generator in queue. It's actually a one-way handshake. Actually, based on certain condition, the queue is actually infinite capacity. Okay, so this is just some hint. We see that this is a one-way handshake. This one we call a two-way handshake. But now the thing is, how can we generalize? Okay, for example, we just set a two-way handshake for all the queue and server. Whether this is possible, whether generator is able to communicate with a queue which have a two-way handshake interface, but generator is actually one-way handshake interface. Yeah, some of the question like this, probably you can think through. So next week, next Monday, I will give you this answer. So actually this one we have already got the answer. Then we implement it in some of in our library. Actually it's ICQ model. Okay, so this is some things I want to discuss and talk to you. Yeah. So I think the next Monday, I will try to identify this a pattern. We will modify what is implemented here by following that pattern. Okay. Then I will start to introduce this RCQ to you. Okay. To yeah, probably we can also play with that. See how much time we have next week. Okay. So I think that's all for today. Do you have any questions?
Yeah, Robin.
Yes.
I have
Yes.
a question.
Yes.
So regarding the handshake, which is when one, for example, this let's say there's a queue and this server is in full capacity, meaning that the queue the server cannot request for another signal incoming to the server, and
Yes.
then the other one, for example, after this server there's another server.
Yes.
uh that means we need to increase the service time, right?
No. They won't. Okay, so I think this is about the definition of the service time.
Mm-hmm.
So usually we see the service time. Okay, let me clear about this concept first. Is when a load is actually at the server. Okay, is the actually okay when the load start to have some relationship with this server. Okay, it actually have a three status. One status is requested but not started. Okay, this is
Mm-hmm.
the first one.
Yeah.
The second one is a started but not finished. Okay, this is the second one. The third one is a finished but it's not departed from the server because of the next one is a start, for example. So each load actually have this three status where they have some kind of relationship with this server. Then if you want to see when the load is physically at the server, okay, so meaning that actually it's already started, otherwise it's still in the previous one. So when the load is physically at the server, so it has two status. One status is started but not finished. The second one is finished but not departed. Okay, so when we see the service time, we actually only refer to the time between the start and the finish. We do not consider the time between the finish and the depart. So what you said is right if it's considered the cycle time in this server, meaning that we consider the time between start and the depart. Yes, if the next one is a start, then you increase the time. But we do not call this one the service time. Service time is only between the start and the finish. This one will be independent. This one will be independent of the next one. And sometimes we also call this active and passive. So if the load is in the server with a status of the processing, meaning it's started but not finished, then we call it's actively occupying the server. But if it's actually finished but not departed, then we call this a passively. This load actually passively occupying the server.
Okay,
Yeah.
then that one I understand if there is a queue and a server handshake. What happens if
Yes.
there is server and server? Because there is a because once this one is done, when the random say telling us, for example, the process is taking 2 seconds, for example, and then in front is 4 seconds, meaning that this one the first server on in front is done, and
Yes.
they should depart, right?
No.
To this.
No. This is actually a problem. Is if you look into this example, if you look
Mm-hmm.
in this example, so if the load is done with this machine,
Yes.
okay, But because this machine is full, they cannot be take out. So what we'll do for this machine, the machine will be occupied. This machine cannot take additional load, although it's finished the current.
Okay. What state changes when that it happen when that thing's happening?
It's the state changing is that this machine inside is actually recorded the two things. One thing is how many loads are currently being processed. The second one is how many loads have been processed but pending to depart. So
Pending to depart.
yeah. So you see that this is a machine. So if the capacity, if the system can be modeled in this way, meaning that the next procedure after machine can be blocked. Okay. Then you see that we need to adding another state variables to this machine. Currently, we do not have. Currently, we assume that the queue has infinite capacity. This is one assumption.
Yes.
The other assumption is the procedure after the machine is also infinite capacity. So whenever this machine finish, they can always go out. But this is not true in many cases.
Okay.
Yeah, so that's why we need to adding additional variable here. So each load here will have a 3 status instead of 2.
Okay, so the delta is happening once they depart and go to the second server. Then that is the calculation started for the service time, right? The
Yeah,
start and finish.
yeah,
Okay.
start and finish, yeah. And also
Okay.
you have another depart. So start, finish, and depart. It can have a time delay between each pair. Start and finish and depart. It can be have a time delay.
Okay.
Then only the time delay between start and end is called service time. The other one is called maybe pending time or waiting time.
Okay.
And because of this, I think this is something I want to mention next week. Is in that case, queue and machine, queue and server are indifferent. They are actually the same. Queue is just a machine with 0 processing time.
Yes.
Right? Yeah.
Yeah.
And machine is a queue with positive processing time, for example.
Yes.
So they actually become the same. So this actually is some finding which are actually very important, very interesting. So that's why in the ICQ you do not see the module of server, do not see the module of the
Yeah.
queue, right?
Yeah.
This
The
is
ones.
actually a reason behind.
I
Yeah,
see.
yeah.
Okay. Okay.
Okay. By the way, I think next week we'll go into more details on this. I think we'll let the others in this group will have some time to digest. Okay. I think this graph is something I will keep using in the future. So better I need to understand what does this mean. This one do not need to be treated as seriously because this is not a true example. This is just some of the fake example I'm trying to make to see how flexible it can be. Okay. But later, I think I will update this one with some real example to show you. Okay, this four will be important. Okay, so any other questions? Okay, so I think if not, we can end today's session.